So hey everybody, we should be live right now. You might be noticing I'm not where I'm usually at. Can everyone see the Word document? So who can see me, who can hear me? Let's see if you're in the chat and you can hear and see me. Who can see and who can hear me? Um, can anyone see and hear me in the chat? Do we have yes? Thank you guys so much. I see one yes in the chat. I can hear and see. Do you guys see the Word document behind me? Okay, good. They got me. So we are good to go. Everyone can hear and see me. You might notice something's a little bit different in here. So if you think, why does this look different? It's because I'm not broadcasting from the studio. I'm broadcasting from my office. And so a little bit, and tell me if the audio quality is good. I can raise it, I can lower it. I had to remake this, and this is a very kind of lower tech version of it, but we are able to stream like this, very easy. One good thing is I was able to make this off screen. The person might tell you in 20 minutes maybe. 15, 20 minutes, I made this because the studio was not able to be opened and we got everything working. So this was able to be done on a Mac in about 20 minutes. So enough about me, more about you because you have a test. And how are the questions doing in the chat? Hey, thank you so much, everyone. I can see you. There is a lot of echo. Is it room echo or is it stream echo? Is it room echo or stream echo? Room echo or stream echo? Does it sound like it's the room echoing? Okay, good. Because if there's stream echo, good. Okay, good. And do you guys want me to raise the volume or lower the volume? Because I don't really have just the room. Good. Awesome. And I'm trying to I was trying to get my window. Let me try to move the window down again. I want to be able to see what you guys can see. I think I know a way to do it. Well, it keeps full screening that window, and I don't like that. Let me try one more time at that. Oh, I got it. Okay. Awesome. I can now see your guys' chat and also see my Mac is just going crazy. So once I stop fighting the Mac, because the Mac just wants to do what it's going to do. And now we are good. Okay. I can see the stream and I can see what you guys are seeing, and I can go up here and I can type. You might see me turning my head like that because I'm looking over here at a second screen which I'm displaying. So feel free to ask questions. We'll start talking about topics here. I don't have all the fun stuff that I have with my way of drawing and everything, but let's start talking about some key topics. What topics do people have questions on? And I don't know if we're going to be able to play the Kahoot, so we might, if you'll go over to the Kahoot video, we'll probably stay here, and this is kind of your stat lab now. There probably won't be the Kahoot, but because I don't really have the good abilities right now, and so we'll probably just stay in here. I see a first question right here. Here's what I want people to do. When you have a question, I'm over here on this screen right now. When you have a question, I want you to do this in the chat. There's my cursor. Setting up something in just 20 minutes. So when you have a question, yes. So I see first, Neely asked a question, Jackson asked a question, and Jackson's first question is, could you go over how to determine population of a sample and a sample frame, etc.? So once again, you'll see me turning my head here. Jackson's got the first question. When you have a question or you want to call my attention to something, tag me in the chat. You saw how Neely did that, and also Ailey's doing that. Tag me. It makes my name go orange, and you'll see I'll like tag someone else here just so you can see your name lights up, and I'm in the hardest time finding my mouse. Like if I were to tag someone in the chat, their name would go orange. So you do an @ and then you tag me, and then I can see it really easily. It calls my attention right to it. More likely to get your question answered. First question is, what is the difference between a population and a sample frame and a sample? So what are the differences between a population, a sample frame, and a sample? Well, let's do some questions right here. We need good definitions of these. The definition of a population is every person or thing we want to understand. So this is kind of like a population of interest right here. What do we want to understand? Maybe we were doing an example yesterday with Dave Ramsey saying, okay, we want to understand millionaires. So think about this. Millionaires is our population of interest. We want to understand millionaires. But then, what is the sample frame? This is a very important word that I think a lot of people forget. The sample frame is all people or things we have access to. Now, what does it mean to have access to something? When we have access to something, it means we can sample them. So maybe the sample frame would be the people Dave Ramsey has on his list of millionaires. So the sample frame, and we do get a formula sheet on the test, the sample frame would be all the millionaires we could possibly speak to. This is where people get confused between the sample and the sample frame. Listen to the key differences here. The population would be millionaires because we want to understand millionaires. That's the people we want to understand. The sample frame would be the millionaires we can contact. Now, I didn't say the ones we speak to. I said the sample frame is the millionaires we could speak to, because the sample frame is a theoretical thing. It's all people or things we could possibly speak to. Last but not least, we have the sample, which I think a lot of people know this. The sample would be the millionaires we actually speak to, so all people or things we get data on. And I see a lot of great questions in the chat. We're going to keep taking all those questions, so keep asking them. I might have to scroll back up, and we'll go question by question right now. And this is like your stat lab. Sorry for all the fun and stuff, but and I appreciate everyone understanding. I wasn't able to stream from the studio today. I was really bummed, and so I went and grabbed a little bit of food, and then I came back up here and set this up in literally 20 minutes. So I knew I was going to like, this is going to be we got this. Okay, so you'll notice, as I'm saying right here, these are the key differences. A population is every person or thing we want to understand. A sample frame is everything we could possibly sample. And a sample is everything we get data on. One of the, and parameter of interest, that's a great one to add to this list. The parameter of interest, or the population parameter. Let's put some different ways it's worded. You can hear population parameter. It's fun looking over the side. Or parameter of interest. Or you might just hear parameter. Or sometimes we'll say population parameter of interest. These are all the same thing. Maybe we're asking a question to the millionaires. I see a lot of great questions in the chat. We'll just keep going, and I'll keep scrolling up. So get your question in now, and I'll do them in order. Remember, this is recorded, so you can go back and watch it. If you're like, Brian, I only have 10 minutes. So with this right here, these are all the same thing that I've written right there. We have just the same thing 4 times, different ways of saying it. It's like saying, I have a brother, or I have a sibling. I mean, I know those are slightly different, but I have a sibling who's older than me who's a pharmacist. I have a brother who's older than me that's a pharmacist. I'm saying the same thing. So if I say the population parameter or the parameter of interest, I mean the same thing. Let's take a look at what's going on right here. The parameter is for a population, which means the parameter is some sort of measurement we have for everybody. It'd be like the average GPA of all UT students. If we're talking about our millionaire example, it would be something like the percent of millionaires who paid off their house in 7 years. So promoting Dave Ramsey again, because a big thing is how quickly you can pay off and get debt free. So he's noticed that with his samples. So he wants to understand for the population of millionaires, because he has a sample of millionaires, right? He maybe speaks to n sample size of millionaires. And then we would see in that sample a sample statistic. What we want to understand. Can't spell. About the population. All of these are the same thing below it. So let's put them in a nice little italices right there. Those are the same thing. They're synonymous words. You're debt-free. Do your debt-free scream. I highly suggest listening to him. I think he's got some great advice. That's just personal opinions there. But if you notice right here, his parameter can also be called population of interest. It's just the population. But those are the people we want to understand. Then the sample frame are the people we have access to, because it's like the frame. It's like ability right now, which are the next questions. And I just made my chat window go away, which I don't want to do. Okay, so let's go right back to here. And let's do it. Okay. Yes, I do agree. I think it's really good stuff. It's personal advice from Brian time. I think you should listen to him and try to follow his plans. Brian gets 30 seconds of Brian talk between questions. That's the rule. And so I really think Dave Ramsey has great personal advice for everyone. That's it. Okay, let's do it. With this right here, we're doing some probability stuff. And so let's talk about the probability rules. I'm going to make a table right here. I'm looking over the table over there you can see we got the boards. We got that table, that green table right there. We're going to add in that green table. We're going to put it right here to practice the rules. Internet. I'm super laggy. Put it down to lower quality, and that's one of the fears. That's why we bought the supercomputer. I. That's why we bought the expensive computer. 1, 2, 3, 4. At least it justifies me. I wonder if how can people hear and see me at a decent rate right now? Can people hear and see me well right now? I'm streaming from a little MacBook Air. So, awesome. Okay, let's continue on right here. Here we go. It just keeps buffering. I'm very sorry for the delays on this, and I'm not hardwired internet. So, let's go here and start putting down our rules for probability. So if you're wondering everything I was just saying one of the really great things is we bought a really amazing PC. And so with this really amazing PC that we bought, I missed that computer. I want to go to the studio and use it. So how long is this review? We will keep going as long as the stream keeps doing decently. So we will keep doing this right here. Is it good when you refresh the page? I'm going to keep doing the rules and everything. Let me type them in right here. Put this table in your notes. I think everyone can see that this table needs to be in your notes. So start putting this table in your notes right now. If you are following along, start putting this in your notes. Can't you, wrong spot. You probably can't guess what's going to go in the multiplication spot, but it's that. The condition right here is disjoint. And then right here, the word for it is, if you made an A in the class, could you also make a B in a class? Are those disjoint events? Oh, it looks like we might have a lot of issues with streaming this. And my computer probably could not handle Kahoot in the least. Oh, so much silence here. I'm going to give the answers as top of this. Usually it's more of a, so when A happens, and technically, and so I'm going to answer some big stuff right here. When you talk about making an A in a class or a B in a class, those are very, very dependent events. Because you would say making an A depends on making a B. Does that make sense? Making an A in a class depends on making a B. So what does dependent mean? It means if you make one grade, you can't make the other, at least in this sense. And these are completely disjoint events. So when are events not disjoint? An event that's not disjoint is something like, could it snow and we have school? So you have to ask yourself this, could it snow? Yes. Could we have school? Yes. This means they are not disjoint, because not disjoint means A could happen and B could happen. Just do it that way anytime I ask two events. Could you go to Taco Bell for lunch and go to Taco Bell for dinner? One of these days we're going to get sponsored by Taco Bell. Could you go to Taco Bell for lunch and go to Taco Bell for dinner? Could that happen? And think about that. Would there be an overlap where you do that on 2 days? Is it possible? Is it a good idea? Different question there. But is it possible to go to Taco Bell for lunch and Taco Bell for dinner? And look, it is. So that would mean they are disjoint or not disjoint. Would they be disjoint or not disjoint? Since one can happen and the other can happen, that's the overlap where two events occur. And that would mean they are not disjoint. That means they have an overlap. Like if I have two circles and they overlap, they have a joint, they have a connecting part of it. But then if they're disjoint, that'd be something like you can make an A in a class or you could make a B in a class. I'm trying to show the circle there. There we go. And so those don't have a joint. You can't make an A and a B in a class. There's no joint to it. You could make an A in a class and pass a class. Those are actually completely jointed. So is disjoint, it is the exact same thing as being mutually exclusive. Exact same words. Those are synonymous words. So you know what we might do? Let's go right here and make sure people know that this is also mutually exclusive. So those are mutually exclusive right there. It's the same word. It's just another way of saying it. So is not disjoint independent? This is where it gets a little bit nuanced. And this could lead to true falses or multiple choices. We've done that before on the test. I had some really good examples earlier on the board today. And listening about this. Sometimes, or at least with this, if something is disjoint, they are completely, and this isn't a sometimes, this is always, if things are disjoint, they're completely dependent. Imagine your favorite sports team. Your sports teams last night, I'm not wearing my sports shirt today, but they'll either win or lose. Let's put no ties in there. They'll win or lose. You can't win and lose because that's disjoint. They are disjoint, so if you win, you don't lose. So with that in mind, winning is dependent on losing. So when you have disjoint events, they are 100%. When you have disjoint events, they are 100% dependent because winning depends on losing. Now, there's more to think about here. Think about this with independence, though. Let's talk about what independence means. So when we say depends, and Walker brings up a great point in the chat right there, you could say something like, school depends on snow. Does that make sense if I say it to you? Us having school tomorrow depends on if it snows. Like, just think about it's January 20th, and we would say something like, school tomorrow is going to depend on it snowing. Does that make sense? School tomorrow will depend on it snowing. Does that make logical sense? Hopefully it does. But think about this. That does not mean that the events are disjoint, though. Dependence means the following. If two events are dependent, knowing that it snows would change the probability of school. So if you know that it snows, that would change the probability of school. Does that make sense right there? If school is dependent on snow, knowing that it snows would change the probability of school. And I see some good questions from Zach in the chat. So that is what dependence means. What does independence mean? Independence means something like knowing Brian went to Taco Bell for lunch says nothing about you going to Taco Bell for lunch. So let's just pick a random student right here who goes to Taco Bell 20% of the time for lunch, and Brian goes to Taco Bell 50%. I really don't go that much. But Brian goes to Taco Bell 50% of the time for lunch. So you can say, what's the probability Brian goes to Taco Bell for lunch and that random student goes to Taco Bell for lunch? Now, do you think Brian going to Taco Bell for lunch would influence a random person to go to Taco Bell? Probably not. It seems safe to assume that if you know Brian went to Taco Bell for lunch, that would give you no information about a student going to Taco Bell for lunch. So with that in mind, what would be the probability that both go to Taco Bell? Well, we would multiply them. So we would have 0.5 times 0.2, and that would give us 10%. So do the math here, or you can see I'll write it out for you. But we would just multiply, if you look at the rule of multiplication up there. We have 0.5 is the probability Brian goes to Taco Bell for lunch, because Taco Bell is awesome. And we just multiply this, and that's the probability that Brian and the student go to Taco Bell for lunch. And not just like that we were like, oh, I went to Taco Bell for lunch. We're like, oh, I did too. So that is the probability of both events happening. Now I want you to notice what I've done right here. I went completely across this row right here. So I've used the multiplication right here to say and in the middle of it. That is correct right there, Braden, that it is 0.5 times 0.2 equals 10%. And we had to assume that those probabilities were independent of each other. So I see some other probability questions, some great stuff in the chat. Isn't it the Weather Channel uses it for precipitation, like 20%? Doesn't it mean it'll be, yeah, it's weird. TW, great question, and they might mean it that way. I don't know. The Weather Channel is so crazy. What if the probability of getting 5 tails in a row? And I think Zach and Braden have gotten some good questions right here. Now, what do you know about coin flips? They're 50% heads, 50% tails, and we might be able to do some decision tree stuff here. And take a look at this right here. This is the probability of getting 5 heads, but it's also the probabilities. I agree with Lucas. Lucas, you get mod status for that today. I've seen you in the chat before, and Lucas, you've earned that mod status. So, there we go. So we have right here 0.5 times 0.5 times 0.5 times 0.5, and this is the probability someone goes to Taco Bell. You'd have to assume, or wait, we don't have to do Taco Bell anymore. This is the probability that we get 5 tails in a row. It was also the probability of Taco Bell. But this is 0.5 times 0.5 times 0.5 times 0.5, which is equal to 0.5 to the 5th power, which is the probability of going to Taco Bell 5 days in a row. Oh my gosh, I'm just going to talk about Taco Bell. Probability of getting 5 tails or 5 heads in a row. You know what we could do? Watch this. We can go right here, and you know what's very interesting? is we do this and this, and we add them. I can't see where there it is. Guess what we just figured out? This is the probability of getting 5 tails or 5 heads. Do you see what we've done here? We have 5 tails or 5 heads is what I've written right here. Okay, this is a really hard question now, and this is a great review. If you've been working really hard, I hope you get this. I want someone to tell me, since I said I just found the probability of 5 tails or 5 heads, what is this probability right here? This is a tougher one than probably the whole test when it comes to probability. If you know what this means and know it very quickly, you are super on track for probability stuff. And we'll do decision tree next year. I think that's a lot of us for decision trees. And it looks like we're back to at least a 5 quality where maybe the stream's not lagging so bad. How are we doing on stream quality? Like at least a 5 now? Maybe? Like not so laggy? So not getting, 0? Oh no, I'm so sorry. So when events are disjoint, they're 100% dependent. When events are disjoint, they're 100% dependent. Because if A happens and B can't happen, B depends on A. So disjoint events are 100% dependent, but realize that they're separate topics. The topics just merge and that they have a joint in that area. So you wouldn't say something is not mutually exclusive, thus they're independent. It's just disjoint events are 100% dependent. Because if you know A happens, B cannot happen, meaning B depends on A. The probability of not getting either 5 heads or 5 tails. Exactly. Walker, great way of writing it out right there. The probability of not getting 5 heads or 5 tails. That means like you get something other than 5 heads or 5 tails. Look at it, it's 1 minus. Oh, we got some mates. Oh, you guys are awesome. The probability of not getting 5 heads or 5 tails. Yep. Try to read it as a sentence. That's one of my key advices here in class is always read it as a sentence. So we would say everything but, 1 is everything but getting 5 heads or, and look at the words up here, this is the cheat sheet, or getting 5 tails. So I like the cheat sheet. It's very powerful to know what rules you have to have, understanding what disjoint means. It's mutually exclusive. Know what mutually exclusive means. Knowing what independent means. Knowing what the complement means. You notice we just used the complement rule. So we just kind of did a lot of this lecture. You just got like a whole mini lecture in like 15 minutes. Does anyone feel like they have a little bit of understanding about probability now? Maybe a little bit? No, you guys. No, I'm still gonna be here. I'm still working at UT. I get to be with the most awesome person ever. So, you guys are awesome. So, but not as awesome as someone else. But yeah. So, but this is okay. Is the formula sheet on the practice test the same? Yep, should be the same. Sometimes we just make it look a little easier to read. The only changes we make are just like aesthetic changes. So you'll get everything that you would normally get. We just make it easier to read. Probably 0.5 times 0.5 is 25, 12.5, 6.25, and you double that. And yep, that would be right. Parker, you're right. Parker, that's the answer. That is the correct answer for the probability of not getting 5 heads or 5 tails. Something other than 5 heads or 5 tails in 5 coin flips. That would be the probability of it. I am a little bit confused. Minnie, and we'll wait here a moment longer. Explain the question a little bit more, and I'll try to. These numbers, if you're wondering about these numbers, this is the probability of getting a tails flip. Yes, Julio, nice answer right there. The probability of someone having type A blood and type B blood, because you can't do that. And so this is also on the practice test. You can't have type A and type B blood. It's just, we wouldn't even call it then that because type A blood means something, type B blood means something. So you can't have type A and type B blood. So let's say this. You ready? We're going to do a trick question here, and I see some more. We'll do stuff other than probability here soon. But if we have the probability of type A blood is equal to 30%, just pretend someone will be like, Brian, it's actually this. I'll be like, I didn't know that. I think O, and let's just say any type of O, we're just going to go any type, is 40%. What is the probability that someone has A or B blood? Yeah, we'll do some of that. I think we're going to do decision trees next, and then we'll do some confidence interval questions. So I think we're going to go decision trees, then confidence intervals. So a lot of decision tree people. What is the probability of having A or B blood? And then what did you have to know about having the 0.5 was from coin flips before. It was like heads and tails coin flips. So it's like, what's the probability of a tails flip? And it'd be 50%. Jessica, you are right, and so is Neely. The probability of A or B blood, someone having type A or B blood, is 70%. Now, what's the probability someone has A and B blood? Who can do that? Be really quick. Who's got it? What's the probability someone has A and B blood? Great, and I love you guys answering questions in the chat. You guys are awesome. I love the chat. What's the probability someone has A and B blood? None. Tim, you are right. So it is not possible. And you might say, wait a minute, I thought we were to multiply those. We don't multiply them, or we can kind of deduce this one, and I'll explain why, because you can't have A and B blood, because they are dependent. Having type A blood depends on having type B blood. If someone has A blood, they can't have O blood. And I said AB, but AO. If someone has A blood, they can't have O blood, so the probability of having A and O blood is 0. You can't have type A and type O blood. You can't multiply these two together. If you multiply two events, I want to see it in the chat, if you multiply two events, they must be what? To multiply two events, they must be what? Just with our general rules that we teach in Stat 201. To multiply two events, those two events must be what of each other? Independent. Nice job in the chat right there. If you have two events and you multiply them together, just with our rules that we use in Stat 201, you are assuming independence between them. You're saying, okay, this is independent of this, but having type A blood depends on you having type O blood. So all this good stuff here. Okay, so what do we got next? Are there any last questions about probability before we move on to decision trees? I'm gonna So it asks find C and D, but if they're independent, if they are dependent, it is we only. And so Zach asked a really good question. Let me make this clear. There's a practice test question that pretty much does this, where it says like, what's the probability you get to work without getting in a car accident, and you get to work and you got rear-ended? So think about that. Can you get to work and say, oh, I didn't get in an accident this morning, and then later you're like, oh, but I got rear-ended. Rear-ended means you got into an accident. So you can't get to work without getting in an accident, and also in that same day get to work and get in an accident. You can't not get in an accident and get in an accident. Does that make sense? They are dependent. Getting to work safely without an accident depends on not getting in an accident. So you will either get to work safely or get into an accident, but they both can occur. But they are disjoint events. It's pretty much to say like complements, like you either get to work and you did get in an accident or you did not get in an accident, and both of those can't occur because they're complements. So so the probability of the two would be 0. Yes, if we said what's the probability you get to work and you got into an accident and you did not get into an accident, it would be 0 because you can't have that because they both can't occur. I hope that explains it. A little bit of a tricky question right there. It's just if two events are disjoint, the probability of them both occurring is 0. If two events are disjoint, the probability of them both occurring is 0. That's probably the best summation of that. If two events are disjoint, the probability of them both occurring is 0 because they are completely dependent. They are 100% dependent. But once again, let me clarify. Dependent doesn't mean disjoint. Dependent means if one happens, it gives you information about the other. The snow example is great for that because if it snows, does that give you information about school being closed? And the answer is yes. But if it snows, does that mean that we won't have school? It does not mean that. Snow would change the probability, i.e., school would depend on snow, but you can have snow and you can also have school. But it would change the probability of this, meaning that they are dependent. If they are independent, if you know it snowed, that would do nothing to you knowing anything about school. You'd be like, I don't know if school's closed. And someone would be like, well, it snowed. And you'd be like, that tells me nothing. But that's not how it works. Knowing that it snows changes the probability of school being closed. Let's do it with this example. Is somebody studying for the exam, does that change the probability of them passing the exam? I always ask this, people are like, nope. And I'm like, no, come on. So does somebody studying for the exam change the probability of them passing the exam? It does. So would you say those are dependent or independent events? Those would be dependent events because knowing somebody studied for the exam would change the probability of them passing the exam. Now, it doesn't mean you can study and pass. Like, there's a whole bunch of combinations that can occur. You can study, pass, not study, pass, not study, fail, and study, fail. Those are combinations, but knowing somebody studied changes the probability of them passing. So those are events that are dependent, but they are not disjoint. So remember, here's your key, write these down. Independent means knowing event A, somebody studied, changes the probability of event B, somebody passes the exam. So sit there and think, I know someone studied. Does that give me information about them passing the exam? It does. I think they're more likely. That means they're dependent. I know Brian went to Taco Bell for lunch. Does that tell me anything about it raining in California? Brian is telling you completely what events right now. Probability of Brian going to Taco Bell for lunch and the probability of it raining in California are very, very what events? They are completely and utterly, I want to see it in the chat. So what do we got? Completely and utterly, Brian goes to Taco Bell for lunch, it rains in California. Those are completely what? Completely independent. Can everyone hear me well? So, Hollis, what do you want me to type? What do you want me to type? Those are completely, and thank you everyone for being here. We're doing everything we can. We got this. So they are completely independent events. Brian going to Taco Bell for lunch and it raining in California are completely independent. Any other last questions on probability? Or, Hollis, what did you want me to write? Can everyone hear, I know I shouldn't ask quality every 10 seconds. I don't have my microphones and I don't have my cameras. I got this. So maybe they'll let me bring home stuff. The supercomputer. I tell you, it's really awesome. And awesome. The 15 different definitions of sampling stuff. Oh, we'll go back to that. Yeah, okay, let me write that down here for you. So let's put a definition on here. Great idea, Hollis. Thank you, Hollis. Independent. Knowing the probability of A does not impact the probability of B. Mutually, shifty is weird. Mutually exclusive if event A happens, event B cannot happen. So, which is disjoint. Let's make that very clear here. But disjoint is the same thing as mutually exclusive. There we go. Okay. Hey, Era, good to see you. We're doing some review right here. So, with everything right here, does that make sense, Hollis and everyone? How are we doing on that? We should be doing all right. Is that good on the definitions? Let's hope we got it. We got Jump Pro. Let's go to open a file. Okay, we're going to open up Jump right here. And let's do, this is the recent, you guys will be like, Brian, we were just doing this. Oh wait, Jump, go up there. Up. Oh no, Jump. 2 seconds. Jump is not being cooperative. Oh my. Well, that's going to be interesting. Well, let's click Jump up here. Sorry, everyone. Okay, let me try. How's chat doing right now? How's everyone doing today? Okay, I'm closing Jump. Oh my gosh. Era came and visited us during a live stream. Good to have you here. Talking about coding and learning how to code. Coding is very important for all individuals. Very much for it. Now, where is... Sorry, everyone, as I try to get some decision tree output up right here. And let's up. Well, why is it doing that? That's so weird. If everyone notices as I move my mouse up. Oh, you know what I can do? I have an idea. Let me make the decision tree and then let me bring it up there. Sorry, I can't see the chat right now. Let's do this right here. I'm going to make a decision tree as we talk. Be asking those questions in chat. And so I am making a decision tree as we talk. This will look similar to your project. And let's hope, and I can probably bring it over a lot of different ways. So we're going to do this. Once again, I'm on a totally different computer today than I usually stream on. And so let's go right here. And let's predict. If, let's see here. Let's predict, I can't think of anything. I think a lot of people did Greek life. Well, nothing wrong with doing Greek life again. Let's do broken bone. Cool. Okay. We have it. Will it go to the top screen? Are you kidding me? It won't. Okay, so we're going to take a screenshot of this. We can do it that way. Okay, this is looking pretty good. Give me one moment here. Thank you, everyone, as I'm constructing a question for this. Okay. And, okay. So, oh, man. Go away, bottom thing. How is chat doing? Hey, everybody. Good to see you here, Adam. It won't let me drag the window up there, which I'm so confused by. Maybe if I go over to, oops. If I go over to here and I try, oh, wow, look at that. That's the secret. Does everyone, okay, everyone should be able to see it now. That was the secret. I just didn't know how to do it. And so, there we go. Okay. So can everyone see the decision tree right now? Let's make it a little bit bigger. There we go. So, hacks. Can't read it. Here, I'm going to try this. Okay, and now, yes. How can everyone read it now? How are we doing on the reading of it? Sorry, as I try to use this is what I've trained for. Is it bigger now? It should be bigger. How are we doing on size? Better. Hey, this is what we talk about on the project. Make graphics good to read, nice and easy. So this is our goal. Let's go a few font sizes bigger. How are we doing on it now? I think we've got some good font sizes. Everyone, are we pretty clear on it? Looks good, pretty decent to read. Okay, what do we got going right here? Okay. Wow, figured it out. I know how to use a computer. Okay, I'm doing a dual screen thing, so. Okay. Who's behind? Carson. I was like, who is behind me? So right here, we've got a decision tree. Now let's look at this. We've got whether or not someone broke a bone. Now on the exam, usually we make it easier to see because we don't print them in color, but we've got yes and we've got no over here. Now watch as I prune the tree up, and you'll notice this is just the people who have broken a bone and the people who have not broken a bone. So now when we go here and we go split, it first splits on gender. So we have male and female right here. So look at the blue right here for the males. There are 610 males, and it looks like more of them have broken a bone. And I want to point this out. I wish I had my tablet, because this is right now leaf 1. I want everyone to look at this. I'm going to highlight it for you to see that this is leaf 1. And leaf 1 is right here. Look at this blue right here. It's the blue up here. Look at the red right here. It's the red right here. Notice how it's a little bit more than 50% blue, and that's what you're seeing down there. So with this right here, you guys are awesome in the chat. And then we look at this one right here, and you'll notice it's about like 66% no. And you look down here, and look, it's 66% no. So let's go ahead right here and go split. Now the fun part comes where we have to click that. That deselects the point. You got to find a spot where there's no points. And so now we have a 3-leaf split. We have leaf 1, leaf 2, leaf 3, and it's split on Greek life. So we'll talk about this here in a moment. And now we have a 4th split on if someone knows what a Roth IRA is. It's not just know what a Roth IRA is. It is, do you have a Roth IRA? So let's look at the people, and I want you to talk about it this way. We got a pretty tricky, oh, that's tough. Ah, man, that's tough to see. You know what I'm going to do? I'm going to go here. I'm going to split specific. I'm going to split on a high school GPA. Okay, cool. Okay, I like it. I like it. Who are the most likely people to break a bone. So a lot of times we put I can't say completely what's on the exam, but I have seen the exam now, obviously. But so how do we? The first split is always right here. Imagine you're gonna drive this road. Like you ever do those choose your own adventures? This is like start here and then choose a left or right path. This is the first split. So it's like choose your own adventure. Here's starting point. Now you can go here, and once you go here, you could go here or here. So the first split is always this. Now the second and third are a little harder to say where they're at because it did split here second and it did split here third. And I chose where to split, which you really shouldn't do that, but it can make the tree look nicer when you're just trying to interpret it for like test questions like we make. But and there's a lot more about decision trees and partition models that we could talk about. This is a huge topic. In the first split, does it mean that 610 males don't break their bones? Close. The 610 right here are all individuals in here. Now here's a very tough question. Are you ready for it? This is a tough one. We're going to start with a tough one right now. How many of the 610 males broke a bone? Who can do that in the chat right now? How many of these 610 males broke a bone? Try to figure it out. I'm doing it as we speak. Oh, that's not some fun math right there. How many of the 610 males broke a bone? And I think I know it. I don't think that's the answer. We'll double check, but good shot at it. It's a really good attempt because this is a tough question. This is one of the toughest ones we usually ask. I'm not saying it's on the test. I'm not saying it's not on the test, but this is one of the toughest ones. I'll explain how to get it in just a moment. So if you notice, when you look at it, just think about this though. Just looking at it visually, remember we said earlier that for the males, this looks to be a little bit more than 50%. I think we just see the answer in here. So great job, Ailey, right there. She is right that it is 157 plus 197. Let's talk about how to get this and how to read the output. I'm trying to... That's awesome, TW. So this right here is, read with me, leaf 1, leaf 2, leaf 3, leaf 4. Leaf 1, leaf 2, leaf 3, leaf 4. The leaves are at the end of the report. Think of it as a tree, and it's an upside down tree, so the leaves are at the very bottom of the report. So the 4 leaves are at the very bottom of the report. So these are the leaves. It's an upside down tree. So with this right here, let's take a look at it. We have right here leaf 1, leaf 2, leaf 3, leaf 4. So wait a minute. This right here is just a combination of what and what. Can I highlight it? I can't. So that right there is a combination of leaf what and what. This leaf right here is a combination of what and what. That is a combination, like if you were to bring it back together, that would be leaf what and what that would go into that. If you bring that back together, that would be leaf what and what. It would be leaf number 1 and 2. So it'd be leaf number 1 and 2, which is, here's where it's split on Greek life, yes or no. So it'd be these 2 leaves down here would kind of go back into it. We'll hold shift this one. And so it'd be these 2 leaves right here would go back into that leaf. And we can do this. Watch. Now, when I go to prune below, it goes back into it. And look, there's the answer we saw in the chat just a moment ago of 197 plus 157. Because those people, which we saw in leaf 1 and leaf 2, are now just in leaf 1. Leaf 1 is now this. So we added together the people who broke a bone in leaf 1 and leaf 2, which was 197 plus 157. And we got how many people broke a bone for that spot. So we're going to do a split. It should split there because it did that before, so it will. And so if you notice here, this 157 represents right here, there are 157 people here. How many people are this red unit right here? How many people would you add the 2 top leaves of? So if you're asked probability, would you add the 2 of the top? Yes. That would be a much harder question. You'd have to divide. And what we could do is we could do 197 plus 157 divided by 610. There, does that make sense? So you would take the numbers and the leaves, and then you would divide the probabilities. Does that? Hopefully that makes sense right there. I think, yep, and this was 27. That corresponds to this down here. That means there are 27 people who are female, who had a GPA greater than or equal to 4.37 and did not break a bone. So always try to read it. Be like, okay, we're going to say these people are female and they had a GPA less than 4.37 and these are the ones who did not break a bone, and these are the ones who did break a bone. Now tell me, who were the people most likely to break a bone in this decision tree? Who were the people most likely to break a bone in this decision tree? Any ideas on who were the people most likely to break a bone in this decision tree? Not just males, not just. Who were the people most likely? Close answers. So look at the very bottom of it. Look at where the blue is at. Blue means broken a bone, yes. Be very specific. Boom, Brad got it. Nice job, Brad. So it is males in Greek life. Now, it doesn't mean that you will break a bone. We have people who were males in Greek life who did not break bones, but it's not bones, plural. It's have you broken a bone is the question. So these are males in Greek life who have not broken a bone, and these are males in Greek life who have broken a bone. If you look at, it's basically like a 70%. We could divide the numbers and figure out. You would divide 157 by 231, and so it's like 65% or something. So a question could ask, what percent of the males in Greek life broke bones? It would be 157 divided by 231. That's another kind of question we can ask, like, what percent of males in Greek life broke a bone? Well, these are the males that are in Greek life. There's 231 of them. We go down here to see there's 157 here, and then that would be it. What people were least likely to break a bone? And you can cheat. Watch this. If you go up here, where's the red at? The red is the fourth leaf, and you go down here and you see that these people right here are, let's follow the pathway, or choose your own adventure. I mean, choose where the adventure goes, but females who have less than a 4.37 GPA were the least likely to break a bone. So these were the people who were least likely to break a bone with, and this is leaf number 4. Remember, 1, 2, 3, 4. Same up here. 1, 2, 3, 4. It's just the order. This is connected. Like this is 1, and this is 1, and this is 1. So this is 4, because this is 4, and this is 4. If you notice, 4 is the biggest leaf. There are 636 people in 4, and 3 is the tiniest leaf with only 62. There are 62 dots inside of here, if I could do it. There are 62 total dots. I might have selected it properly, let's hope. But there are 62 total dots inside there. And there's my accent, dots. I am not, there we go, got it. Would test questions ask us about the lowest leaves? Yes. These are called the leaves of the decision tree. We could ask about these, but this is like not in the leaf report. So this would not appear in the leaf report. But like, let's ask about this one. The leaf that I've highlighted right here is the combination of what and what leaf. And I called it a leaf, sorry. The branch, I should say, or the node it's sometimes called. Those are females, but females are made up of what leaves? What leaves would be the people who are female? What leaves would be the people who are females? What leaves? Remember the numbers. 3 and 4, you got it. Leaves 3 and 4, which is the split on high school GPA. It's the ones that we split on high school GPA, and that's just how it's split. So leaves 3 and 4. So down here in this output, and I can't highlight just those numbers, but in this output down here, it would be the 3rd and the 4th leaf are the 3rd and the 4th right here, which are the same as the 3rd and the 4th inside of here. This is leaf 3, this is leaf 4. So these individuals right here, I'll highlight them. These people are all female. And look below here, you can see that these are all female. They're all under the subcategory female. Practicing reading this output is a very important skill, just knowing what it means. I want to also point out that you can see the Y variable here is broken a bone. And then you can see yes and no. So make sure to realize that this is on the Y-axis. We are trying to, and then we'll do R squared next, we're trying to, and great question, Haley, thank you so much, because I was like, we didn't cover that. We have Y, we have R, oh my gosh. We have Y right here, which is whether or not someone's broken a bone, yes or no. And then we have the X variables below it that give us information or help explain. X is explain. So the R squared, write this down, or why not? I'll write it down for you. Let's do it. Blank percent of the variation in Y is explained by the variation in X. We good? Oh, we'll do split history next. I'm just having a little bit of fun right there. Blank percent of the variation Y is explained by the variation in X. Do a little magic trick right here. Boop, magic trick. Blank percent of the variation Y is explained by the variation in X. Pause the screen or take a note on it. Blank percent of the variation, oh my gosh. You can say variables. Either's fine. The tree has variation in it due to the x's. Sorry, I do so much regression that my mind wanted to say blank percent of the variation in y is explained by the variation in x, which is, or you could say the x's, and the x's are in the trees. But r squared is always a percent of variation explained. Don't do that, Brayden. Terry, you want to make a guest appearance?
All right, I'll make a guest appearance.
Terry's coming off for a guest appearance. The question in the chat is, can we use 48 font for the next project? What do you think?
Oh, 48 font and have a project at 1,000 pages.
1,000 pages?
Not only should it be 48 font, but I think it should be something fun like the Harry Potter font.
That's what we're gonna do. There's a Rick and Morty Get Swifty font. That's I did an intro with that. So extra credit for each page. Oh no. Oh gosh.
Oh well, yeah, the extra credit 0.0001.
No. So we've got the R squared interpretation right here. This is my makeshift broadcast studio. Got it up and going in 20 minutes.
That's awesome.
And watch this. We go boom. We're back to jump output up here.
Sweet.
So so when you look at this, we only have 3.4% of the variation in whether someone has broken a bone is explained. They said the two masters. Terry, we're getting some kudos right here. 3.4% of the variation in whether or not a student's broken bone can be explained by the variables in the tree. Great answer right there, Ailey. Amazing work. And so knowing that, being able to explain that, 3.4% of the variation in the y variable, which is broken a bone, can be explained by the variables in the tree. You got it. Oh, Terry's getting some votes for BP. So for MVP or VP, they're awesome. So thank you. Thank you, everyone. All the positivity. Love it. So split history was asked. Split history, take a note. We'll decrease font size. We're going to lose some points here, but we're going to decrease font size. So what is the split history? Let's put definitions. Leaf report shows us the distribution of the y variable and the x's that split to get there. Split history shows us the increase in r, I can do this, squared after each split. Would be good to have a good outro with this. Good outro. What's a good outro? There we go. Split. It's fun looking over at the screen and be like, I'm gonna spin my head around. So the split history, and there's some important things to know about this. Some important theory stuff. It's so far away, and I'm so blind. Oh my gosh, look at that split history. It's horrible. If you notice, you see some weird stuff. This is where I was redoing my splits. Wow, that's kind of cool. But this is not. Look at that. This is when I was like undoing, redoing it. We're getting like an interesting split history here. R squared just did not do too well in this tree. R squared really had a hard time. How do you know the boys are blue and the girls are red? Double check. The boys are over here. The blue is people who broke a bone. Because, and great question right there, so the blue is the distribution of the y, and so the y variable is, have you broken a bone? So you see how this is in accordance to the y-axis? So the boys are all the people inside of here. The males are people inside of here. If you notice where this goes to right here, and this is, this is leaf 1 and leaf 2. So those are all males, and if you notice, it says males right here, and this is leaf 1, leaf 2. Those are where the males are at in leaf 1 and leaf 2. And then all the females are over here. And look where it says females right there. This is the small leaf 3. This is the big leaf 4. And leaf 3 and leaf 4 go into this right here. Great question. No, amazing questions. That's why I love covering this stuff. Because people, every semester I get asked those questions. It's very, once you know how to read this output, it makes a lot of sense. But it's a lot going on. You've got lots of variables. You've got a y variable. You've got multiple x's. And what's going on with it. So great question. Thank you very much, because I'm sure a lot of other people are like, I still don't get this output. Let me ask this. I need some. This is what I like hearing in chat. Who feels like they understand this output so far a little bit better? Like, let's say a good bit. I want you to say in chat a little bit, a good bit, a lot. Who feels like a little bit, good bit, a lot? Or you could be like worse. That would not make me feel good. But how are we doing on looking at this output now? Yes, we got a yes right there. A little bit. I like a little. A good bit, a little bit. I'll take a little bit. I'll take a good bit. So we did a little to a good bit, slightly. Practice is good. Uh, that's all right. But not the split history. You know what? It's time to talk about the split history. And then if you want a definition, we'll define anything you want. Okay. That's Braden. So glad to hear that. Okay. And then we'll go back to the doc here in a moment. And then infinitesimally. Zach had killed me. That's awesome. Okay, split history. So I want you to watch what happens to the split history here. I'm going to close the leaf report, and I want you to notice when I prune the tree, do you see how it goes backwards? It's showing me r squared after each split. So it's showing me r squared after each split. So watch as I keep splitting as r squared increases. Sorry it's got the zigzag. That's because I did things I shouldn't do if I'm making a tree. So usually you will not get that zigzag, but watch this. Ooh, that did a pretty decent jump right there. What happens every time I split the tree? Every time I split the tree, r squared does what? Every time I split the tree, this is a good theory thing about it, every time I split the tree, r squared does what? Every time I split the tree, r squared goes up. We've asked questions before that say something like, we do 2 more splits on this tree. So here's a good question. Look at this output. Does everyone remember what r squared is? R squared right here was 0.056. Very bad, or 5.6% of the variation whether someone has broken a bone is explained by the variables in the tree. Braden, great answer right there, Braden. So we have here, Brian now adds in 2 more splits in the tree. What is the value of the r squared after the splits? Brian adds in 2 more splits. Brian adds in 2 more splits. What is the value of r squared after Brian adds 2 more splits in? What is the value of r squared after Brian adds 2 more splits? The answer is D. How do we know this? This is a theory question. It has to be D because what do x's do? When you make more splits in the tree, you're putting in more x variables. It can use the same one again, but you generally see different ones if you have a lot of variables. It's sifting through there trying to find the best things that explain. Nice job in the chat right there. I see some more variables explain the y variable. So what does r squared mean? Once again, r squared is not r. We like to say that a lot, that r squared is not r. R is correlation. R squared is kind of correlation squared. Not exactly in this sense. R squared is literally in statistics known as the coefficient of determination, which is also the percent of variation in y explained by the variation in x. We're in my office. I might eventually close the door, but it's fun. People walking by me, I'm like, hey, what's going on? But does this make sense here that if we do more splits, we would have to explain more variation? So it could be, it's any number that's greater than our current r squared, because if the tree actually does splits, then it will increase the amount of variation explained in y. It wouldn't go lower, and it wouldn't stay the same. And great question why, and I'll keep trying to explain. It's because when you do more splits, r squared must go up. Ignore the zigzag. I was doing different splits there. So it's a pure theory question. Great question, Hollis. It's pure theory that when you do splits, r squared must go up. If you take the same tree and split it more, you're putting more x's in. And what do x's do? They explain. And look at the definition of r squared. The percent of variation in y explained by the variables in the tree. So if we add in more variables, we will explain more. So with more splits, more variables, more x's, more explaining. So exactly, and that's it. These answers, Hollis, amazing answer in the chat. It cannot stay the same, so that's not possible, and it definitely can't get lower. And the tree would, if a person, big theory person came in, like, well, maybe it could stay the same. There's ways to make it do that. And they'd be like, what if you have a holdout? Don't worry. That's where we get into predictive analytics. That'd be fun. But in 201, we're not using holdouts. This is how decision trees work when you train it on some data. If you were to split enough to where all the variables were included in the tree, would r squared be 1? That is Ali, so everyone, I say this sometimes, I say as a joke, like, everyone close your ears. Ali, you bring up an amazing high-level question. We would call this overfitting. I was kind of even verging into that topic a moment ago, so don't write this down. This is where Brian rants on something for 1 minute. We call that overfitting generally, and that's also something we use in, why can't I think of it, that's how we do our random forest a lot of times. So this actually goes into a very high level topics and statistics. And so you generally don't want to split your tree ridiculous amounts if you're just doing an individual tree. But then Brian mentioned random forests. And that's where like each tree gets to vote on it, because what's better than one tree? A whole bunch of trees. What do you call a whole bunch of trees? A forest. So we call that a random forest. And the forests are using different techniques where we make resamples of our data. It's so much fun. This is actually a very high level topic in statistics that we kind of open up in Stat 201. A lot of textbooks really don't even go into it for 201. If you notice, my Pearson doesn't have assignments on it, because this is a topic that is so new and so powerful that a lot of textbooks for 201 are like, yeah, that's not a common thing that intro students learn, but this is a very important topic. Partition models, decision trees, or predictive analytics is so huge. We teach it in 320, we teach it in 474, and this is a lot of how predictive analytics are done. And it's a very, it's things we couldn't do 20 years, you could do it 20 years ago, but it wouldn't be as easy. Computers have made this very, very possible. I mean, just think of how cool it is that it's sorting through all these variables. So that's my quick rant on that. You could do it, but your tree would probably be overfit. And don't worry about those definitions. So we wouldn't split it endlessly. If you were able to split so everything was in its own leaf, R squared would be 1. So Ali, great theory question. If you did split till everything was in its own individual leaf, you would explain all the variation in the variables, but that would be overfitting. Practice exam question 7, part 1. Why are we dividing by 10? What does the question say, Adam? And I think next we were going to do, was it confidence intervals? I think confidence intervals was next, right? Am I right or wrong? I think it might be confidence intervals. Oh, is it the randomness question? If you can put it in the chat. Oh, yes, Braden and Adam, thank you so much. Here, I'll give the problem. I know which one exactly you're talking about now. Okay, so a grocery store is going to give away gift cards to random people. They draw numbers 0 through 9, where 0 and 1 are winners, and 2 through 9 are losers. Then it goes down here and it says A, and it says according to the simulation, what percent, no, not according to simulation, the way the simulation was conducted, the way the simulation, how does it say it? No, it's totally because there are 2 numbers that are winners. I'm trying to think. The question has a specific wording that says like the way we created it, or the way the random numbers are created, or something. Oh, did I mess it up? Yeah, 0, 1 are winners. It can be 0 through 1, or 0 and 1 are winners. Does that make sense? So why does it not like gift cards? Those both are words. So the way we chose the numbers for winners and losers, what percent of the time should someone win? Now, the first question is not based on how they coded the integers. Thank you so much, Adam. Based on how they coded the integers, which that's kind of what I've written right there. The way we chose the numbers, which is how we coded them. The way we coded the numbers, what percent of the time should someone win? So if you notice, 2 out of the 10 numbers are winners. So the way we coded the numbers, 2 out of 10 would win. Now the thing is the next question goes into simulating results. So next question is like, okay, with these simulated results, what percent do we observe winning, or what percent are there 3 winners? So then the biggest thing, and I'll say this, when you see simulations, take a note right now. When you have to do a simulation, take as many, do as much as you can on the page. I tell my graders that someone could get the simulation question wrong, and I'd only have you take off 1 point. Like, let's just say you make a little error and you show all your work. Well, if you know how to do it and you just make a little error, well, then I'm going to take off 1 point maybe out of 5 because you know how to do it. You just made a math error. So you still get 4 out of 5 points. I mean, you don't want to lose a point, but a lot better than not showing your work. But you can still get it right. If you don't show your work, I always say that, like, right answers are right answers. If you get the right answer, that's great. But the only way to get partial credit is to know what you were doing and to let us see the process. So always show your work. Always write at least like as much as you want, and then if you do a bunch of solving, circle your answer. speaking on this side of the grading, circling answers helps so much. Oh, please circle your answers. It's so amazing. And then it's like we know clearly which one you're trying to tell us is the answer. So circle your answers. Just helps with grading because your eyes just go, boop, that's the right answer. Great, student got it. But if it's not circled, like, okay, there's their work, there's this. Wait, oh, there's their answer there. So it speeds up grading for us. So I might even announce up for this, like, hey, circle your answers. It really helps with grading, and I'm sure the graders will be very happy. And so what can we do to get partial points? Always show all your work. I can't state that enough. That like anything you're thinking, if you're like, I don't know if they'll give me partial for this, just write it down. Error on the side of showing more work than you think you need, and then circle your answers. That way, if you were to show a bunch of work and it was like, we didn't know what you were doing, that could hurt you maybe, but circle your answer because we don't want to get lost in your work and not know, wait, where did they get their answer? We'll be like, oh, there's their answer. That's right. That's the first thing we do when we grade questions. We just look to see if it's right. And if it's right, full credit. If it's blank, no credit. Those are the easiest questions to grade. The hard ones to grade are when you're partially right, and then we have to be like, okay, this is a 5-point question. If they made a math error, I'm going to give them 4 out of 5. If they understood it but made some major errors, maybe 3. If they knew something, 2 out of 5. If they knew anything, 1 out of 5. That's generally the way I grade a 5-point question. So it's like, what percent of the question did you know? Everything 5, nothing 0. Math error, 4 out of 5, because it's like, I basically got it, but you made an error. Still wrong, but you knew it conceptually. Does that make sense, Jessica? That's always my advice to graders. I'm always like, I want you to understand that 0 means it's blank. So especially with 5-point questions, if you get it wrong, we shouldn't see like 0 out of 5. Unless you just like had no idea. If it's like a question like this and you answer like the way we chose the numbers and you answer stats is awesome. If that's your response and you're like, I want a point because I read stats is awesome, I'm like, well, it is awesome, but that's not something that shows knowledge in the area. The true or false is what brought my grade down so much. Is there going to be a full 10 of those again? I think there's like, I think I can say that. Let me see here. Terry, can you hear me? Do you know how many true false? I can say that, can't I? How many true false are on the exam?
100.
100. It's all true false, all with 1 point each. How many true false are on the exam?
7, I believe.
7. So it's 3 less.
Points. So
3
7
less.
2 points is 14 points. Don't make it a landmine for your exam. Know the concepts.
There you go. I'll be right, Terry. I'll let you on.
Well, I gotta go to. I got my 340s.
Do it. All right. So when asked the probability, should we answer in decimal or percent? Either one is acceptable. But here's the thing, and I'll be right back in about 30 seconds. I'm back. Okay. True, false. Great question on how do we say true, false, and then we're going to do some confidence interval stuff. So true, false, a lot of it is theory. So when it comes to true, false, tons of it is theory. Like the question about, like you can make up your own true, false. Like you have to think of like flashcard stuff. Yes, I'm going to mention that here, Ren. That's the next verging topic. So, reading everyone. So, if we had something like, here's a true-false question. Every time a tree splits, r squared will increase. True or false? Every time the tree splits, r squared will go up. And I think I've got some homework help videos. Yep, true, very true. Something plus its complement is always 1. Something plus its complement is always 1. That is also true. let's say the sampling the sample frame is equal to the population for a census. The sampling frame is equal to the population for a census. That is also true. Oh, everyone thought I was going to go false. That is also true because a census means you take information from everybody, which means you want to understand everybody, which means you need access to everybody. So listen. We just said what a census is. A census is you want to collect data on everyone in the population. So to collect data on everyone in the population, if you make a census, you would have to have access to everyone in the population. So a census means to collect data on everyone in the population. So you'd have to have access to everyone in the population. So the answer is true. In a census, the sampling frame is the same size as the population or the same thing, because you have access to everyone and you want to understand everyone. Does that make sense? I know I threw a trick there because everyone's waiting for that false, and I was like, I'll throw one more true. So a little tricky right there, but it was very much based on definitions, flashcards, knowing what a census is, know what a sample is, knowing what a sample frame is, know what a population is. Let's do a little bit of confidence intervals right here, and let's make our own questions. And I think, I know, right? And here's the thing. You can ask us questions. You are very right that the U.S. Census isn't really a census because we might not get information on everyone, but a census literally means to get information on everyone. So the U.S. Census is like as best we can do a census. So the sample frame is like as best we can do a sample frame. So, but a census literally means by definition to get information on everything. So that is the definition of it. So you can argue that the U.S. Census does not achieve the goal of a census. So does that make sense? Braden, you bring up a really great point right there. And will you type? Sorry. What do you want me to type? I'm sorry. So population. Well, we did. I'll do it. Is every person or thing we want to understand. A census is equal to taking data on everything in the population, and then a sample frame is equal to every person or thing we have access to. Yeah, we can do that real quick. Yeah, we didn't do that earlier, so let's do that. Okay, so the different types of sampling methods. Who wants to do sampling methods or biases first? Cool, Braden likes it, I agree. I think we could do that right now, and then we'll do confidence intervals next. We're not going to do the Kahoot. I'm going to stay on this video link, just because if my computer's having a little bit of trouble with this, Kahoot will really give it trouble. So I hear methods first. Let's do methods. So we're going to go back to Dave Ramsey as an example I did in class. So it's new to people who weren't in class yesterday in my class. So Dave Ramsey wants to understand millionaires. So he goes out and he's got a list of millionaires, and we're going to do what's called a simple random sample. Maybe we'll do donuts. I need to come up with new examples. It's either donuts or millionaires. A simple random sample. First, the first step to a simple random sample is give everything in the population a number. 2, select those numbers randomly. I know we need the jelly beans. With everything going on, I didn't get the jelly beans. I need those jelly beans. So, jelly bean sample. So we have right here, I like Walker's advice. I agree with Walker. So we have give everything in the population number, select those numbers randomly. So we would need to have a list of millionaires. They would all get numbers like you're millionaire 1, you're millionaire 2. It's just random numbers. And then we select random numbers to talk to. Now someone might say, why don't you just talk to all of them? Well, one, there's the 10% condition for some of the statistics we do. So that would violate 10% to sample more than 10%. We're throwing a little bit of chapter 13, part 2 in here. So we don't want to sample more than 10% to not violate the 10% condition. But also, it would take too much time. Someone mentioned that in class yesterday that sampling takes time. So it would take too much time to talk to like 10,000 millionaires. It'd be like, we don't got the time or energy or resources to do this. So we give them numbers, and then we call them up, And we could get things like non-response bias, throwing that in there where they hang up on us. That's non-response bias. But a simple random sample gives everything in the population a number, and then we select those numbers randomly. Okay, so next we have a systematic sample. And try writing these down with me. Systematic. I knew I spelled it wrong. That says systemic. So systematic sample is, and we'll probably be able to stay on this page right here. 1, choose a random starting point. Landon, I think, has or Fisher asks, a good question right here. And then 2, I'll answer that question here right before I do this. Choose a random starting point. Choose every kth observation. There we go. And so if we repeatedly randomly sample the central implies that a sample size 2. Oh, is that on the true false? Yeah, I need to remove that question. I removed some stuff off the test, and Fisher, ignore that question because this semester we slightly changed the coverage of exam 2, and that answer would be, and it should be false. It depends, though. If that's the full question, that sounds false to me. It would depend on the shape of the original distribution. And don't worry about that. That's exam 3 now. Just we shifted the exam, and I need to remove that. I'm very sorry if anyone looked at that true false and saw it. I updated the coverage and everything. It looks like I missed one true false question. So good question right there, Fisher. Sorry that was on there, and you're like, what is going on with this central limit stuff and the shape of the sampling distribution? So that will not be covered on this exam. But it's saying you repeat the 2-person sample over and over again. Don't worry about that one. Don't worry about that one. That one requires us to know the nearly normal condition, which we don't know yet. So we'll talk about the nearly normal next time in Stat 201. So nearly normal is coming up. So with systematic, we've got this list. Fisher, that's awesome. I like it. Fisher, you got some mod status right here. We're making Fisher a mod. We're having some fun today. We're relaxing, just talking topics. So right here, I think I see. Sorry, I did. Wondering if that would be needed to be an antecedent. So I'm gonna answer Connor's question real quick right here. If an item is only purchased once in a cart, then would it need to be an antecedent or consequent to have a confidence in the rule of 1? So an item is only purchased once. If an item is only purchased once in like 5,000 cards, then it would need to be in the antecedent or consequence to have a confidence. So if it had a confidence of 1, it would need to be. It'd be interesting because given that someone has, I think it wouldn't always have a confidence of 1, Connor, because imagine this: we have a specialty item at our store, and then we have milk. So we could say, given someone buys the specialty item, what's our confidence that they buy milk? And only one person bought the specialty item. So if that person also bought milk, then it would be given someone bought. It would be in the antecedent, because that would be a confidence of 1 or 0 because you're only talking about one person. Because given someone bought the specialty item, they bought milk would be 100% because there's only one person. So if that person also bought milk, the confidence would be 1. But if that person did not buy milk, the confidence would be 0. If it's in the consequent, then it would be given someone bought milk, how does that influence the probability of them buying the specialty item? And then we would have, it makes sense. So my confidence of somebody buying the specialty item given they bought milk, yeah. So how does it? And so I think that. Sorry, that was a 474. Okay. Oh, is it? Send me that. I might have just. Sorry, my brain might have just hiccuped on that. Is that what you were thinking too, Connor? So I need to sit down and look at that one real quick. I need to draw it out and I need to write out the equation for it. You did the math? Okay, I'll hop back to 201 right here. Sorry. Maybe there's an error. There could be an error. There might be. And were you finding, this is the last thing I'll say on this, were you finding that? So hopefully, I need to do the math on it. I just need to write it down. I'll write it down and I'll come to the test and I'll give you a sheet of paper showing it mathematically. And so I'll give you the answer to it before the test. I'll be like, here's the answer to it. Okay, let's talk about the remaining sampling methods. Okay, so here we are and we have choose a, you're welcome. Thank you, Stat 201. That was a little side right there. Systematic, choose a random starting point. And then we choose every kth observation. So this would be Dave Ramsey goes to his list of millionaires and he would need to generate a random millionaire, like millionaire 3,482, just randomly generated. That's the first step. And then he would need to choose every kth millionaire, which means every like fifth or 10th. He would just be like, this millionaire, this millionaire, this millionaire, this millionaire. Does everyone understand what systematic is? Because we're going to get to the fun ones right now. So now, here comes the tough ones people make mistakes on. The tough ones people make mistakes on are cluster. Cluster is going to be, indented it. I did not say indent. I said, that's what I said. So we go right here. So I'm so sorry we can't do the Kahoot. My computer can't handle it. I'm so sorry. So we have right here cluster. Randomly assign elements to groups. So randomly assign, we could just say individuals or elements to groups. So we're going to randomly put things into group. That's a key thing. I am so sorry, Ashton. We do have the one from last semester that you can still watch. You can find it on the YouTube channel. My computer just won't be able to handle it. Go to last semester's Kahoot. It's posted. My computer just, if you notice how much it's struggling for this, Kahoot will break it. Especially if someone were to Kahoot bomb us, my computer will go and it'll start to take off. It's just floating in the air with the fan going crazy. And I'm glad to hear this is very helpful. Just go on to topics. Boom. So randomly assign individuals into groups. And then we have, once we randomly assign things into groups, and I'll probably be streaming tomorrow also. I'm going to try to do as much as I can to help you guys out. We got this. So randomly assign individuals into groups. Clusters, like you say, are given numbers. I don't know if I've always said that, but you'll hear why I'm breaking this apart right here. Randomly pick these numbers. So everything I say is always the same sort of communication here, but let's go over the steps of what's going on right here. Are there specific groups that are clues for being clusters? Yes. On the practice test, I think it talks about flights. So if you look at different flights, a flight is a cluster of individuals. Now I want to make clear what a cluster is versus stratified. Clusters are randomly put together groups. Sometimes they're like kind of random, but we're saying we're going to go and take a whole bunch at once. That's what a cluster is. Now be careful. Why would you not say, and just think about this, we ask people about parking on campus, and why would you not say, well, let's cluster based on ag campus versus main campus? So, and I forgot something. They said this yesterday. Take all individuals from the cluster. So you take data on all individuals in the cluster. Take data on all individuals from the cluster. So why, and that's kind of the key point I'm getting at right here, why would you not cluster on ag campus or main campus? And so hopefully, Alexander, a great question, because this shows where we would not cluster, because main campus and ag campus are not clusters. They're strata. Because if you treat them as clusters, do you think it's random who's on ag campus and random who's on main campus? Is that random? Is it completely... don't worry, Jeff is fine. I don't think he's saying anything too crazy. Don't worry about using mod powers unless someone's being... unless someone's like saying things they shouldn't. Like if someone comes in here and starts saying like really rude things to everyone, then bring the mod powers, since we are like live. Ag campus and main campus are going to have different views on students. It's not random. Emma, great job right there. So ag campus versus main campus are not randomly assigned groups. How about, let's just say we go to Neyland Stadium and we take random rows with the row of people in Neyland Stadium. If I just say, let's just take 50 rows of people in Neyland Stadium and ask them what they think about the football game. Would we be doing clusters then, or does that sound like strata? If I go to 50 random rows in Neyland Stadium, I take every row and I choose 50 random rows. Does that sound like clustering right there? Here's some key examples, so you can try to tell where I'm going with this. Does 50 random rows selected in Neyland Stadium sound like clusters? I would say yes. That would be clustering. Now you might say, well, the people in the rows might be different. Like you've got student sections. If you say student section versus like just general public section, that is strata. So student section versus general section is strata. But then rows by themselves, if you just say, let's get 50 rows, the rows are clusters. But when you do strata, which we'll talk more about here in a moment, always good to differentiate between the two, we're going to be right here. Sorry, Kevin, my computer can only handle this today. So would academic class be strata? Great job, Allie, right there. You're getting it because freshman, sophomore, junior, senior are not randomly assigned to those. There's differences. That's why let's talk about the definition and make sure we know that when you have strata, you are going to first acknowledge a difference. So stratified sampling is going to be, we'll put sampling a bit higher. Stratified sampling is going to be first acknowledge a difference. And what do I mean by this? Rows aren't really a difference. I mean, you could say, well, the rows are different, but it's just like row A, row B, row C, row D. And you might be like, well, some are closer. But we're not saying people who sit near the game and people who sit far away. We're just saying, let's take a bunch of rows. Well, they're just rows. I mean, there'll be different ones, but it's just random rows. So I like to use donuts for this because what is a cluster? We're going back to here. What is a cluster of donuts? If you go to Krispy Kreme and buy a cluster of donuts, what would be, no worries, I think everyone knows, and that's why I let everyone know, just if someone comes in, like let's say someone's spamming the chat, definitely time them out or remove them. Definitely do that. If they're like, hey, then just be like, okay, you're gone. And we don't respond to them. So a dozen donuts is a cluster of donuts. You are right. A dozen donuts is a cluster of donuts. So how would we stratify donuts? Now, I think where people get confused is because clusters are groups, but they're randomly put together groups. Like a box of donuts is pretty just random. Would a box of same... Now be careful. Don't worry about the type yet, because Allie's pointing out type and flavor is strata. So what you would say is if you went to Krispy Kreme and you said, just give me a box of donuts, hopefully they would kind of just put random donuts in there. But you notice we might need to stratify and say, give me a box, cluster, of glazed donuts, strata. Give me a box, cluster, of assorted donuts, strata. So glazed versus assorted is the strata there. We've actually made a multi-stage sampling now. Multi-stage is when you combine together multiple methods. So think about this. Let's go to the Coca-Cola factory now and we'll complete the definition of stratified. Stratified is first, acknowledge a difference. 2, sample randomly within those differences. So we have right here stratified, and I think I can get this all on one page. So let's bring this back up right here. And we got this all pretty much on one page. Stratified, okay. So we're gonna go, glazed donuts are the best by far. Boston cream, or they've got a cake batter donut now. If they ever made a birthday cake donut, don't listen to this Krispy Kreme. I'd probably walk by Krispy Kreme on the strip every morning if they had a birthday cake donut. Like if it had, I'm not a big fan of icing. A birthday cake Boston cream donut. I'd walk to one. I'd walk down to campus. I'd get it. I'd be like, hey guys, I gotta go to lunch. And I'd be getting like a dozen of them. All right, so the box of glazed donuts would be a cluster. Be careful, when you say glazed, you're acknowledging a difference. We'd probably just want to say a box of donuts. Chocolate ice cream. We've got some votes on one of the best donuts in chat. I like it. Cake batter donut is superior. Good stuff with those donuts. And people like the Boston cream donut. So when we talk about different types of donuts, we are definitely doing what? Oh, you're fine. You're back, Jeff, and you're welcome to chat. No worries. And sorry about that. Yeah, you're totally good now. Sorry about that. And I appreciate all the mods. So as long as you're talking and having fun with us, Jeff, we welcome you here. And you're doing that, so we're glad to have you. So we've just had people come in the chat and say some crazy things every once in a while, and then we're just like, eh. So if I'm replying to you, you're doing great. So awesome. So whenever can we go to how many people you should sample? Oh, yes. I think, Madeline, you're asking, I'm going to drop some major hints. I don't know if I can set up a second scene here that quickly. Okay, you guys are going to see some craziness right here. You ready? Okay. So we're going to go big screen right here. Okay. So I'm going to turn the camera, and hopefully I lost power. So if you look at this equation, It's going to be, is it mirror image? That says P hat times Q hat Z over ME squared. You want to take a screenshot of that? It's mirror image. I'm very sorry. That is P hat times Q hat, and then Z inside of the squaring of it, ME, and then squared. And maybe I'll put that, we've been doing that question a lot. Sorry, I'm all zoomed in right now. So let me change this back right here. I don't have all my cool layouts right now. I don't have my cool fun stuff. Let's bring the chat back here, and now we can see everything. I think there we go. Okay, good. Let me plug power back in before we start losing power. Okay. Oh, thank you guys so much. Vlog time. We walked to the test one time. We did a whole Zoom thing, and that's the last time I used it on this computer. Is I was like zooming to it. So I'm totally not in the studio today. Oh, this room is not super fun. It's kind of boring, and I just moved the chat again. And we want to do some really cool stuff. So one thing I want to say is especially, so I think, here, we'll finish with this. Here's Brian's 30-second rant again, is we want to do some really cool stuff with this office. Hopefully we want to get sponsored by some really cool people. And then we're going to do there'll be screens in here. And next semester, like if you're taking BAS 320, or if you just want to come up and work in like Brian's studio area in the fall, I want to have it so there's screens, there's computers for people to use. I'm hoping someone like Dell or someone sponsors us, and then we could be like, this is a studio office, and you'd come in here. There'd be really nice chairs. We got good chairs now, but we'd go better. And you could just come up here and do work, and then I would appear on the screens. So you'd be like, you'd see me on a screen in the background, I'd be like, hey everybody, I'm here in the office, and it'd be like super high tech. And we're even talking about Robot Brian. So we got a lot of big ideas, big orange big ideas. This is all okay saying. What classes do you teach? I teach 201, 320, and 474. I've taught some other classes like 310, 471. I've taught 207. Honors class is so much fun. That's one of my favorite ones to teach. But we want to make a high-tech office. So if you know people or you're watching this video now in the future and you're like, hey, I could put Brian in contact with some people, do that. I just need to find a good sponsor. And we want to make this office look super cool. We'd put there, as long as we get it put through UT and everything, regression. Oh, yeah, modeling. Yeah, totally. I love regression. So we can do a ton of regression. So if you like those classes, come say hey, take 320, take 474. Yes, Jeff, you might want to rewind the video. See if you can rewind it back in time. And we went through that as like the second topic. Does that make sense, Jeff? We could come back to it near the end, but we did that as like topic number 2. Here, wait, I can like watch this. Oh, you can see something cool. Here, we're gonna like go back in time. Go back. We gotta go way back in time. You ready? We're going back in time here, everyone. This is like, we're time traveling now. We're going back to 1985, the year of Back to the Future. Oh no, Derek, I think our time travel stopped. Oh, we got stuck. We can't go that far in the past. I was gonna bring it all the way back up, but that's as far back as we can time travel. We'd try to go to 1955. This is my last thing, and then I see a lot of questions. And then we'll do the biases next. Easy way to remember Back to the Future time travel, 1985, 30 years back, that's the first movie. 1985, 30 years forward, so it's 30 years back, 30 years forward, so 2015, which is the past now. And then 1985, 1885 is the third movie, 100 years backwards. Okay, lots of questions. We had our fun. We got our break. We've been going for about an hour and a half, so let's keep talking. The different biases was the next question. So we're going to do a little more sampling here, and then we'll do confidence intervals, and we'll cover it a lot. This video will be posted after. You can check it out. The different types of bias are voluntary. We're going to misspell this. Got it. Response bias. A voluntary response bias or a voluntary sample. Oh, and then we need to do that. Ren, we'll do that next right here. Voluntary response bias is when you put out like something in the newspaper. So people who volunteer their, I swore it was right. Their responses differ in their opinions than the population. Because we want to understand the population, another definition of population. We want to understand, the people we want to understand, which is the population. There's something we want to understand about them, the parameter of interest. So maybe we put out something in the newspaper and we say, We want to know what people think of a new local restaurant. Who is likely to respond to the newspaper when we say, we want to know what you think? I'm good right now. Thank you so much, Carson. You guys are awesome in the chat. I actually literally ate right before this. That's what also was a slight delay because I was like, I'll just go over to the studio and stream. And then I was like, can't stream in the studio, haven't eaten, can't, got to set this up. So people with strong opinions, Dylan, you are 100% right that people who respond to the newspaper are the ones who maybe ate there and loved it. The people who ate there and totally didn't like it. And think about that. If you went to the new restaurant and you ate there and you're like, well, that was okay, and you're like, you see some in the newspaper, you're like, I don't want to respond to that. But if you had the best experience in the world, you'd be like, oh my gosh, you got to go to Stock and Barrel. You got to go to Taste of Thai. You got to go to Hard Knocks Pizza. And if you haven't been to those places, Taste of Thai, Hard Knocks Pizza, and also Stock and Barrel, you got your best burgers, your best Thai food, and your best pizza in Knoxville. That's my opinion. So if people were to ask people's opinions on those, you might get some voluntary response bias. So with all this right here, we are working with all students, Olivia. So we are working with all students. We're doing everything we can, so please communicate to us any concerns you have. Email us, and I promise you this, and sorry if anyone's like, hey, Brian, it's taking you a while to respond. I'd say last night I responded to like 100 emails. The day before, I responded to 100 emails, and the day before, there's a lot of emails. But please email me, and please realize that it might take me a moment to respond, and I will always be answering every email. Any concerns you have, please give us those concerns. We're working with anyone. If you feel like you're immunocompromised or you're worried about other things, please talk to us. We're working with everyone we can. Also, and I do say this seriously, if you are sick, please do not come to the exam. If you are coughing, so talk to us, talk to your instructors. We'll communicate with you. So please, please, please just talk to us. We're going to have everyone take the exam in some time frame. This is the best information I can give. But please, and let me say this very clearly, one, if you are sick, do not come to the exam. Two, if you have concerns, please come talk to us. Please email us, and we will work with everybody on something that is fair to everybody, which is something we are working on as best we can. And I think everyone understands, right, that we are going to be fair and we are going to work with everybody. But please, and I do mean this, I don't want to, like, this is where Brian gets serious. If you are coughing and you're like, I'm fine, I think it's just allergies, don't come to the exam, even if you are coughing and you have allergies. We will work with everybody to make sure everybody takes the exam in some way that is fair. We will be working with you and communicating, but we want everyone to come to the exam who's healthy and feels good about coming to the exam. So please communicate with us, and that is the information that we are doing. But once again, I cannot state enough that if you are feeling sick or if you are displaying symptoms that could be, concerning to people around you, do not come to the exam. Does that make sense? And I think everyone kind of understands that if you are coughing, things like that, do not come to the exam. And we've sent out emails regarding that. How's everyone doing on that? We get some awesomes in the chat. And we are making sure we have everything in line. Thank you for everyone. I think everyone knows we're all trying to work. If you watched the stream yesterday, I promise you, thank you, Olivia. I'm glad to hear that. Thank you. I like seeing some awesomes in the chat. We're doing everything we can, and people yesterday were saying, they had concerns, which really valid concerns. So yes, as long as you are healthy, we want you to come to the exam. And if you have concerns, please talk to us, and we will work with everybody. So that is our goal. So awesome, great to hear that. So, and just talk to me about anything, email me, and once again, another disclaimer on that, I promise you I'm replying as quickly as I can to every single email, and I appreciate everyone who knows that. So I will get through all of them tonight. Watch me have like 700 emails. I don't know. But I will try. I will probably be responding to emails while I'm giving an exam to somehow mitigate that. Let's calculate the probability. Fun stuff. Okay, so we have other biases. The other biases are going to be convenience bias, and that is the word I can't spell. Convenience bias. I broke my brain, and I can't spell convenience. I've never been able to spell that word, and I can't see it over there. Does that say convenience? Convenience. I think that does. That looks good enough. Good. Hard to see from over there all that's going on. Convenience bias is going to be when the way, yes, email your proper instructor. And we've done internal communications, and hopefully we've made it clear to everyone in our classes. But please come to us. Please email us and talk to us if you have concerns. So awesome. Convenience bias, when the way the survey is done creates a bias due to ease of survey, or I guess ease of survey. That kind of puts it clear. So the ease of the survey, what do I mean? Let's say you want to figure out what the average on the first 201 exam is. Your teacher told you the average in our class was an 80, and you're like, wait a minute, I talked to my 10 friends, and the average was a 90. We're going to save some good friends today. So I talked to my 10 friends, and the average was a 90. What kind of bias did you put in there? Hint, it's the one we're talking about. You did a convenience bias because you talked to the easiest people to get to. So talking to the first 10, things like that, doing it in such a way like putting your survey, imagine we did this one in class, if you were to do a survey of people on Instagram to what they think of your photography skills, then it would be like, okay, wait a minute, I'm talking to my friends on Instagram. That's not really a good representation of what general people think. Now, you might get a view of what your friends think, but you're also getting your friends who kind of visit your page. So you wouldn't really have a good representative view. So that is very much convenience bias. So that is when the ease of which it is done creates a bias that is not representative. And you keep hearing me say this representative word. We would get that this is a not representative sample. It would not be representative of the population. Now we get into the fun ones. We get into response bias. Response bias is going to be when the way the question is worded or the person gives bias in their response. It's just about how people might give a response that's not true to what they believe. We use classic examples like this. Is it fair that, I'm giving a biased question, that's the goal of this, is it fair that you can go to war at 18? You can buy a house at 18? You can be in college at 18? You can be married at 18? You have kids at 18? You can do all these things, but you can't buy a beer at 18. Is that fair? No one says yes or no in the chat. No one has any opinion. So all of that right there, with all of that, I put a ton of bias in that question. Literally just even the phrasing of it, is it fair? We did the Dave Ramsey one in class yesterday. Steven says, no, that is not fair. We did the Dave Ramsey one in class yesterday where we ask, if someone really wants to be successful, do you agree that they should follow the Dave Ramsey plan? And that's such a biasly worded question. And a lot of times these are multiple choice or sometimes fill in the blank. So if someone really wants to be successful, do you think they should follow the Dave Ramsey plan? Where is the question there? Just break that down. Break it down to just the question. If someone wants to be successful, do you think they should follow the Dave Ramsey plan? So where's the question and where's the bias pushing a response? The question is just, should someone follow is the Dave Ramsey plan effective? That's it. And you could do really horrible things with the question. You could say, Dave Ramsey has shown that 95% of the people who follow his plan achieve financial freedom or financial stability. He is the man still, though. I agree with that. So Dave Ramsey has shown through his plans that 95% of people who follow it are able to achieve financial freedom. Do you think people should follow Dave Ramsey's plan? So you would want to just ask, do you think people should follow Dave Ramsey's plan? What you should probably do is, if you really want to get people's views on it, which is not saying if the plan is good or bad, you'd probably you would go to Dave Ramsey, you'd have him list his baby steps, which are like, do you save up your 1,000 first? I don't know. See, I should know this. I'm such a big fan of him. It's like you pay off all your debts, you save up your 1,000. No, you save up your 1,000 emergency fund, then you pay off all your things. So you list out all these. Step 1 is 1,000. Step 2 is pay off highest, the snowball, the debt snowball is next. Pay off the snow, then the snowball. Man, I should know this. Then the debt snowball. Then step 3 is pay off your house, right? Oh man, you guys are good at this. See, we're getting some Dave Ramsey promotion right here. So I think you guys should look into it. If you're trying to be debt-free, very good plan, very good advice, and watch his videos, something like that. So what we would do is if we were doing this without response bias, is we would list out all of these steps, we would show them to people, and then we would say, do you think people should follow this plan? Now, there is some issues like we might not call it the Dave Ramsey plan because maybe that might put bias in there. This is where surveying is just totally fun because it's very hard to do. Step 3 is invest. Wait, no. Braden is messing with. That does not sound like Dave Ramsey to me. Is it buy Bitcoin? It doesn't sound like Dave Ramsey either. You guys are awesome. This is why I love teaching online. So this is I love the jokes in the chat because I'm pretty sure those are jokes. If I heard step 3 was buy penny stocks. So SPCE, I don't know what that is. I know I've heard the acronym, I think. I know. Response bias, the way in which questions were, the person gives their bias and response. Non-response bias. And then we need to do some sampling after this, and I might have to go. Non-response bias is when the people who don't respond differ in their opinions than the ones who do. Now, I think the Dave Ramsey example works really great here because when you look at it, still promoting Dave Ramsey, good stuff. But if we were to contact the millionaires who Dave Ramsey knows, and they were like, oh, I don't really want to talk about Dave Ramsey, I think the people who don't want to talk about him, like if they know we're calling about a Dave Ramsey survey, I think they would differ in their opinions on him than the ones who do want to talk about him. It's almost like we're verging a little bit into voluntary response bias then, because you're saying like these people are volunteering their opinions. But these people who are not responding to us, like it might be that they don't want to like share a negative opinion. They might be like, it's all right. I don't really do surveys. And you're like, oh, okay, cool. But it's because they differ in their opinions. There you go. So these people differ in their opinions. Does that make sense on what non-response bias is? It's also hanging up calls, like when you call people and you're like, hey, I have a question, like click. But you'd have to assume that they somehow have a view, like if you were to call people about the presidential elections and they hang up the phone, they might have different views than the people who are willing to speak to you. So it almost kind of connects a little bit into voluntary, but voluntary is more about the people having strong opinions who talk to you, and non-response is about the people who don't talk to you. So when people refuse to talk to you, like they're like, I don't have time for that. That's non-response bias. When people are jumping up, they're like, hey, me, I've got a big opinion. That's voluntary bias. Like they're like, I would love to talk to you about this. If you wanted to ask if the y-axis on Ward's D for the dendrogram is different from the y-axis on, yes, that is very true. The y-axis on hierarchical clustering with Ward's D on the dendrogram is the within cluster sums of squares. So the y-axis would be the within cluster sums of squares, which is calculated by how far each point is away from its cluster center. And then on usual dendrograms with linkage, with single, average, and complete, that is based on the distances, and we don't have that graphic up today. That is based on the distances observations are away, and that is computing single linkage, the 2 closest points, so that'd be the 2 points near my nose right here, and complete linkage is the 2 furthest points to calculate those distances. A great question, Livia, right there, and I'll try to intersplice those 4 Singapores. They are taking their exam very soon here. So you're welcome, Livia. Good to see you. So we saw Connor earlier and everyone in the chat. So what about scatter plots? Scatter plots won't be on this test. Scatter plots are regression, which is a great topic. Thank you, TW. That's awesome, Juan. So, and then we have one more bias right here. Who knows it? It is under coverage. If you notice, these kind of coincide a lot. We're going to do a throwback question here in a moment. Under coverage bias is when we leave out a certain, we say voice in the survey by not having enough of these individuals. Okay, so what is undercoverage bias? They're all covered pretty well. We try to make as even as a topic. You want to say, hey, Dr. Panel, to the internet?
Hey, internet.
You want to be on camera or no?
No.
Oh, you don't look on camera. So we're doing the stream right now. The studio was occupied. So we got, look at that undercoverage bias right there. We got undercoverage bias. They can see the screen that I have over there. So what is the most heavily covered content? Oh, see you, Dr. Panel. So, and then we're going to do that next, Marissa. Great question. Thank you to everyone who's here. Marissa and Max and Braden. Awesome stuff. So undercoverage would mean like if we did a survey about parking on the ag campus. So Alan's getting some shout outs. If we did a survey on parking on the ag campus, where would the undercoverage be? If we did a survey on parking on the ag campus, what would the undercoverage be? If we did a survey on parking on just the ag campus, like we say we want to understand all UT students, let's go to the ag campus and talk to people because it's kind of nice. You got the gardens down there, you got the vet school, great place. So what would be? Yeah, we would undercover main campus. Now wait, are you saying no main campus students walk to ag campus? They do. A lot of main campus students, and what we mean by a main campus student, we mean someone who primarily has their classes on main campus, like we look at Haslam College of Business, and then why can't I think of the name? I remembered it yesterday. The ag school, can't remember the name of the ag campus or the school, the ag school. Jumps out of my head because I Haslam every day, but I got some UT pride today, UT school. So we'd probably be over covering some and under covering the other. So I think people understand what under coverage is. So now let's do confidence intervals. Okay, let's come up with a confidence interval question. Here we go. So a confidence interval question would be something like, can't see my font size down. Okay, you ready? Confidence interval time. Here we go. We go out. Herbert, there it is. I was about to say it. I knew it. Thank you very much, Sydney. So we go out and speak to 300 students on the main campus. Oh wait, we got to add something in here. We need our random word. And ask them what they think about parking. 210 there are 210 who tell us it's not awesome. That's our view. It's not awesome. Create a 95% confidence interval to estimate the true proportion of students who think parking is not awesome. So when we do this question, key stuff right here, we need to identify all the notation. So let's start out right here, and we see 300. Who online can tell me what 300 is? Start marking this on your test when you see it. You see 300, what are you going to write on that? I want to see it in the chat. So when you see, okay, wait, yeah, let me fix that. I'll make myself smaller here. 2 seconds. I think I can fix everything. Oh, no, go down here. Here we are. There we go. There we go. Should have it. There we go. 300 is the sample size. So what is 210? What is 210? 210 is equal to, and this is the one I always pause on. This is when people forget. 210 is equal to what? 210 is equal to what? What is 210 equal to? It is X. Nice job, Jeff. Amazing work. And we're going to use that to get P hat. We're going to use it. Be careful. Remember, P hat, take a note on this. P hat must be a number between what and what. I want to see it in the chat. P hat must be a number between what and what. P hat is the sample proportion. So, and P hat is X over N. And so X over N is P hat. And it must be between 0 and 1. Great job, Marissa, right there. So people writing in the chat, 310 over 300 is P hat. It must be between 0 and 1 because it's a proportion, so we know the proportion. If you notice I chose a nice number there, it's 0.70 or 70%. Question earlier, at the end of your question, you could turn it to a percent, and then you could say the true percentage. Probably just keep it as a proportion. It's usually how we talk about it. But we should give the full points if you do it as a percentage, because a proportion is a percentage. So a percentage is from 0 to 100%, and a proportion is from 0 to 1. So we know proportions must be some sort of decimal, 0 to 1. And so we see here 95. Now there's a really good question earlier. I'm going to make this thing here that's going to help people out, hopefully. If you're doing the homework assignments, you can use the David M. Lane, but here's the most common ones. I don't know them all off the top of my head, but we need the z-scores. So the David M. Lane will get you these right here. These are the most common z-scores, and they will be given to you on the test. So I am giving them to you right now because they will be given to you on the test. Notice, as I go down right here, the z-scores are getting water. As I go down, the z-scores are getting water. As I go down, the z-scores, I don't want to mess it up. I think those are all correct. I think I haven't messed it up. The z-scores are getting smaller. You could even do something right here like a 68.26% confidence interval. I think that's the correct decimals on that. Does anyone have hint 68? Does anyone have a guess what the z-score for a 68.26% confidence interval is? 68. What is the z-score for that one? What is the z-score for that one? Which is not one we ever make, but what would it be? Hint. Don't think too hard about it. Just think 68. The z-score for that one would be 1. So that is a z-score of 1. So it's roughly and that's the decimal place accuracy down to 2 decimals. And if you notice, we could go up here just so everyone kind of understands that these are coming from the empirical rule. That's kind of what I'm pointing out here. Is 99.7, and there's actually a 3 after it if you carry the next decimal, is actually almost exactly 3.00. And notice as we go from 68, 95, 99.7, the z-score gets bigger. So is xp? X is the number of successes, so x over n is p hat. So there were a total of 210 students who told us parking's not awesome out of 300 total students. So 210 is the number of successes, and 300 is the sample size, so 210 over 300 is p hat. P hat is the number of successes over the number of samples. 210 successes, 300 trials, and we see here 0.7 is p hat. So we'll put here that this means the sample proportion is 0.70, and that's p hat. So p hat is the sample proportion in notation. Let me figure that out. Yeah, that is a tough one. I'll even admit, I like the randomness one a lot, and I created these assignments. The sampling one, the wording on it, the test is much easier. I always tell my students, if you make an A on the sampling one, you're probably pretty good for the test, because it's super tough. Just the way they word it. I love the randomness one. I love every other chapter. I need to work on the sampling one. It's like the quiz I'm the least happy with, because some of the questions are like, what are you asking? Because they're like, what kind of bias is this exactly? And you're like, well, it could be these two. Don't worry, I look at those too, and I'm like, that's a tricky one. And we're always trying to shape and reshift the homeworks between semesters, so we're always improving them and adding, subtracting questions, which then changes it up each semester. And everyone hates the randomness one. I love the randomness homework. It's my favorite one. But that one's tough, but extremely fair. Okay, let's take a look. Yeah, let's see that. I should be able to get it. Okay, so let me, Jeff, I think I can do that. Let me try here, Jeff, to do that with you guys. Okay, let's do that. So give me a second here, Jeff. And so give me a second. We're going to finish this problem, then we'll annotate the formula sheet, and I'll probably have to go. Exams, exam prep, exam 2, review material for exam 2. And there's lots of videos. Hopefully everyone's been checking out the videos. We've got lots of help videos. Okay, so we've got this right here. Let's download it. Wait, that's the wrong one. Wait, did I upload the wrong thing? Ooh, my computer sounds like it's taken off. That's not what you want to hear. Okay, so let me download this. Is there the download button? Okay, so 2 moments. We're going to have this downloaded, so I'll see chat here in a second. And okay. Sorry. Okay, let me do this. I don't know if we can get that, Jeff. I think I might have covered it. Can everyone? Okay. We won't be doing the Kahoot because my computer can't handle it. Sorry. And we do record it. And we will be probably from the studio tomorrow, and I'm hoping I can use it as much as we can. So get ready for live streams tomorrow. And then we might even make, I know what I'm going to probably do. I might see if we can make a lot of the lessons I have public, or I know what we're going to do. Here's what I'm going to do. So everyone, because I'll probably be heading out in about 10, 15, 20 minutes. How would this sound? I'm going to ask people around if it's okay, but I'm going to make the lectures available for the for my online class. They have a playlist of the online videos we have. So I'm going to ask the instructors to send it out. And if you know someone in the class, or post it in a GroupMe or a Discord. But we have a list of our online lectures which cover all the topics. So if you're really struggling with a topic, like let's say you're like, I just don't understand this confidence interval stuff, because we'll finish this question, I might head out. If you don't understand it, how would that sound if we send out that playlist, which has the unlisted videos where I've streamed the class section? How does that sound? So I think that might be a big help. So if I'll try to disseminate the word as fast as possible. I'll send it out. As long as I'm going to clear it with everyone, I need to talk to everyone. So I've got a group chat. But since the streaming's been a little bit harder, I'll try to send out an announcement. You know what I'm going to do? Everyone watching right now, as long as everyone's okay with it, I'm going to put it, I might just do it as an announcement. All right. So I'll look into that, and I really appreciate everyone. I just want you to know we're working super hard, and you guys are working super hard. Thank you, and we're going to keep working hard for you too. Great stuff. Okay, let's finish this question right here. What am I doing? I'm writing all the z-scores. So, okay. So we are not going to use all these z-scores, but this will help for our assignments. We only need the following one. We only need, yep. I think it's sarcasm. I sent a lot of campus announcements. I sent like 3 in like 10 minutes. I was like, oh, people are gonna hate me. Okay. So now, I believe, when do they close? Do they close tonight? Get them done tonight. I think they close tonight. I like to send announcements, but I'm pretty sure the homework's, it's either tonight or tomorrow night, and I think it might be tonight. Sorry I didn't send an announcement about that. But it's before the test. And look, because they have due dates on them, so check the due dates. Okay, let's go to insert. That's where I have to crane my head. Let's go to equation. We need an equation right here to help out. Okay, so we need to do p hat. Where is that p hat? Right here. So we're going to go p hat. Oi, can't see. There we go. That's a real far look. Oh, I think Walker, nice job. Great job solving the problem right there. So this is what I want you to do. When I write these problems, I want you to try to solve them as I do them. That's where you'll know it really well, is if you're following along and you solve it with me. Look at that, copy paste, so beautiful. And we go here, and we do this. So we have p hat, which is the sample proportion, plus or minus z, which is the 1.96 I found, and then p hat and q hat. Now, you guys ready to play the p and q game? P and q would work the same way as p hat and q hat, but p is the true proportion. Why is this not a true proportion? Because it came from a sample. So p hat is going to be 0.7 here. If p hat is 0.7, what is q hat? We're actually reviewing what the complement is. If p hat is 0.7, what is q hat? Q hat in this example would be p hat times q hat. We don't want that under that. P hat times q hat over n. Do I do 300? 300. And then this goes here. And sure, I think that'll work. Yay, it worked. 70, and then this is 1.96. There we go. We got it solved. P hat and Q hat add up to 1. So I do want to mention this. Probably about we're about to end, and I'll take some last few questions. Walker gave an amazing interpretation in the chat. I think Walker is right. It looks like that's right from what I know about intervals, and that looks about right. He said, I am 95% confident. Let's write it out. This is very important for test 3. Very important. I am blank, shift key, you're supposed to work. I am blank percent confident that the true, get ready for it, there we go. Okay, so I am blank percent confident that the true blank is contained in the interval blank to blank. This is what Walker did, but look at the big part he had to fill in. I am, easy part, 95% confident that the true proportion of students who think that parking is not awesome, that's the long part, that's why I made part 2 really long, is contained in the interval 64.81, and we got the equation there, 64.814% to 75.186%. If you notice, I want you to estimate, I want you to look at his interval, I'm going to say it a different way, 65 to 75, what is the margin of error? What is the margin of error for his interval? So 65 to 75, what was the margin of error for his interval? 65 to 75, what was the margin of error? The margin of error is just half the interval. So what is the margin of error of his interval? Does anyone know? The margin of error was about, I'm just rounding it, 65 to 75. There you go, 5%. So think about this. I always ask the questions this way. If lunch is going to cost between $6 to $8, what's the margin of error? Well, think about this. 6 to 8, 7's at the center. So what's the margin of error? $6 to $8. What is the margin of error for $6 to $8? Remember, it's the plus or minus. The margin of error would be, it is everything after the plus or minus. I'll be careful. 6 to 8 has a margin of error of 1. It's half the interval. So whenever you do the margin of error, remember, it's half the interval. So good review right there. Margin of error is half the interval. Here's where we're going to end today. We have condition 1. So here's where we practice. This is something I get ready for test 3. I'm always kind of preparing everybody for the next test with the current test. That's my goals. So condition 1 is what? I want to see in chat, if you're one of my students, I want you to be like, condition 1, randomness. Nice job, Jeff. Condition 1 is random. If you notice, we pass because we randomly selected individuals. So we have here that it says random in the question. So we spoke to 300 random UT students. And condition 2 is what? Condition 1, condition 2. And I do it this way because we're going to do the same conditions for tests and intervals. 10% less than, I like it right there, less than 10%. On the test, I would write that we have sampled less than 10% of UT. 300 students is less than 10% of all UT. 300 students is less than 10% of all UT. Now the last condition is success failure. It is that NP hat and then Q hat are greater than or equal to 10. But do you know what NP hat is? Pause. Oh no, Walker. I haven't given out points, but Walker, you get 10,000 points for that. I forgot to say pause. I was going too quickly. Be careful. Be careful. Yep, or it'll only be success failure right here. So we only know success failure right now. And success failure is when it's categorical. Great job, TW. Like people saying pause right there. Yes, pause. Because right now, it is at least 10 successes, at least 10 failures. But condition 3 will change. That's why we pause. We say, okay, wait a minute. What kind of data am I dealing with? Since we're doing categorical data, it's at least 10 successes, at least 10 failures. How many successes were there in this sample? Who can tell me how many successes were there in this sample? Any ideas? It does have to be categorical. And that's, we don't really do a condition on that. Braden is right, that there's 210, and then there's 90 failures. And there'll be a different third condition later on. And there'll be a fourth condition sometimes. We'll practice that when it comes up, so don't worry about it too much now. But there were 210 successes and 90 failures. This is NP hat, and if you want to try with NP hat, you can do this right here. What is 70% of 300? What is 70% of 300? Any guesses of what? And we don't have the power. It's like, you can't use hoverboards on water. You need more power. You need power for that. I think he says, hey, bozo, you can't use hoverboards on water. Back to the Future 2. Such a good movie. Does anyone remember that scene in Back to the Future 2? It's my last little rant for the day. It is... Like, there's been some good movies lately. Like, Infinity Wars is amazing. Endgame is good. Like, I'd say Infinity Wars is the last movie. No, what am I saying? Spider-Verse. Spider-Verse is... Here's Brian's advice. Brian's giving some life advice right now. Over break, watch Into the Spider-Verse. I haven't seen Joker yet, so no Joker spoilers. Waiting to watch it. So, which I'll tell you my opinions when I see it. Who has seen Into the Spider-Verse, and should others see Into the Spider-Verse? This is Brian's last little rant of the day. I see a Brian in the chat. You can't get no spoilers. You can't say anything about it. You can't say good, bad, anything. You can't say any. So Spider-Verse is great. They should watch Spider-Verse. Spider-Verse is excellent. Oh, the art style is amazing. So go watch Spider-Verse. So check it out. Watch Spider-Verse. I promise you I'll see the Joker. Spider-Verse is like, we left the movie, and I was like, that was really good. And she was like, Chelsea was like, was it better than Deadpool? And I was like, she's like, thinking about it, right? And I was like, yeah. She's like, it's better than Deadpool, right? And I was like, yeah, it is. Because I like the first Deadpool was amazing. That was a ton of fun. But Spider-Verse was just like a roller coaster of emotion. Spider-Man 1 and 2 are good. Spider-Man 1 and 2 are excellent. Like the Tobey Maguire Spider-Mans, those are great. I also like Tom Holland, I think, is doing a great job. I wasn't a big fan of Andrew Garfield. Sorry, Andrew Garfield. I'm not a big fan of Dark Phoenix. Yeah, so that's not out yet, is it? I need to catch up on X-Men stuff. So did they do Dark Phoenix? So I don't know. Yeah, I think this is my last little. This is Brian taking a 5-minute break before he goes and teaches. I think Andrew Garfield made a decent Spider-Man, but he was a really bad Peter Parker. He was like, "Hey guys, I'm a skateboarding dude. I'm totally cool. I'm winning in life." I mean, Uncle Ben died. That's what happens to Uncle Ben. Sorry, Uncle Ben. But he wasn't. It's coming out in June. Oh, cool. I need to catch up. I really liked Logan. Logan was great. If you've seen Logan, Logan was a great movie. Yes, there's another great movie. Logan was just Hugh Jackman getting to be Hugh Jackman and being Wolverine. I want that that they say that was another universe, or like that was another time split. Maybe they have, but I want him to come back. Tom Holland is, I would say, he's like, I give him an 8 for Peter Parker and a 9 for Spider-Man. I give Tobey Maguire a 10 for Peter Parker and a 5 or 6 for Spider-Man. So Tobey Maguire was like the quintessential Peter Parker. His Spider-Man was good, but I think Tom Holland does a really good Peter Parker and an amazing Spider-Man. Do you know The Boy in Iron Man 3? Yeah, I know. That was so cool that they did that. Same actor and everything, right? And there's like a bunch of different things with cheeseburgers, because when Tony comes off the plane, when he gets back from captivity in Iron Man 1, they're like, what can we do? He's like, get me a cheeseburger. And then I think his daughter at the end of the thing was like, oh, I'd really like a cheeseburger or something like that. Like, or Happy Hogan says like, let's go get cheeseburgers or something. So there's kind of that little thing right there. Yeah, Andrew Garfield was way too cool to be Spider-Man. Yeah, I give him he gets like a 3 for Peter Parker and a 6. I'd say he did a better Spider-Man than Tobey. So he was a little bit better in Spider-Man than Tobey, but his Peter Parker was, I didn't know. And Miles Morales, he's his own Spider-Man. I mean, he's Spider-Man, but they're playing Peter Parker Spider-Man. He's playing Miles Morales Spider-Man. But so I guess it's a comic, so he's a 10 out of 10 on both. He's perfect Miles Morales. Yeah, okay, Miles Morales gets a 10 out of 10. He's a perfect Miles Morales, and he's a perfect Spider-Man. And you know what, the Spider-Man in that, just go watch it. Go watch Into the Spider-Verse. Okay. You guys are cracking me up in the chat. I took piano lessons After the guy that played the drums in the Star Wars theme song. Ah, TW, that's awesome. That guy was like 20, right? So, what's your opinion on the original MJ on what's her name? I know it. I can see Kirsten Dunst. Um, I thought they did a really good job with that. I think in the first movie is just kind of magical. When I first saw it, there hadn't really been a really good. This is Brian's break between giving a test. The first movie was just really magical, and it just worked so well. And the second movie too, when he saves her at the end, when the Doc Ock like rips down the machine, everything starts falling, and like Spider-Man like is grabbing the thing, and he's like, hey, just trying to save the day, and he like throws it backwards. That's also an homage. There's a common thing where Spider-Man. This is something people might not know. Spider-Man is often caught underneath a great weight. So in sorry, I'm giving a lot of spoilers. In the new first Spider-Man, Spider-Man has the building brought down on him, and he sees, I think he sees, does he see Tony Stark then? But he's caught underneath a really heavy weight. Even in Avengers Civil War, Captain America knocks the thing down on him and pins Spider-Man down. So it's a very common, I don't know if it's an homage, but I guess a trope, you might say, that Spider-Man is caught underneath a great weight. So you've got Civil War, Captain America knocks the thing down on him. You've got the first Spider-Man movie, he gets caught there. Even in the latest, I don't want to give away in Spider-Verse things. There's some Spider-Verse things about it too. Watch it. So there's some Spider-Man. Next Marvel movie, I think they're saying Dark Phoenix. I'll have to get caught up. I'll have to watch it. Wait, wasn't Dark Phoenix already out? I thought it was. Before you go, do a question that could possibly be similar. Okay. So here we go. I'm gonna leave you guys with this question. Or did you know in the last Spider-Man the world finds out it's Peter? Well, that's I know, right? That's man, Spider-Man Far From Home. Spider-Man Far From Home was very good. What's his name? Jake Gyllenhaal, amazing Mysterio. His Mysterio was up there with the likes of Heath Ledger Joker. That's the other Joker. Black Widow, that'll be fun. That looks more fun. And fun movies are good, so we'll see everything coming out. Okay, so we got Black Widow, we got Dark Phoenix, we got everything. I want the next Spider-Man movies. Those are so much fun. Okay, so here is a problem I will leave you with, and I will maybe tell you the answer. Okay, so let's say 80% of Marvel movies get a fresh rating on Rotten Tomatoes. What is the probability that at least one of the next 5 Marvel movies will be rated, will not be fresh? Will not be, so I think that's what they call it. So is that, I think that's what they call it, Rotten Tomatoes. So what is the probability of this? So this one, if you know how to do these, I'm going to do it real quick. You need to draw a number line. This is in at least one problem. You need to draw out the number line here. Let's do some tabbing. I had it. There we go. Okay, so we have that either all the movies are fresh. You should have 5 attempts. We have here that either all the movies are fresh or at least one is not fresh. Does everyone see what I have right here? I've kind of highlighted that either all the movies are fresh or at least one will not be fresh. Does that make sense? Just think of it visually. Either all 5 movies are fresh or at least one is not fresh. We did this example yesterday too. So when we solve this, what are we actually solving for? We're solving for everything but all the movies are fresh. And so I'll solve it right here. And then, nice job. If you solved it and you got it, you are on track. Once you learn the trick to these problems and solving it like this, and check out yesterday's lecture, which I'll try to send out. I go through deeper examples of this and walk through it slowly. I'm doing it a little bit quick here, but this is why I like coming up with problems. So it's everything but all the movies are fresh. So if you look at the way I'm writing this right here, this is everything but all the movies are fresh. Here's the probability of a movie being fresh. That's the probability of a movie being fresh. Here's the probability of all 5 movies being fresh. And then, so be careful. I think what you have, if you change this to 0.2, this is everything but all the movies are not fresh. So that would actually look like, it would be these movies here. Look at what I'm putting in blue. That's what you're finding right there. That is everything but all the movies are not fresh, which means at least one is fresh. So that mathematics, no, great question. Thank you for asking it. This is just the practice we need. When you read it, always try to read it, everything, which is 1, but the movies, all 5 of them are not fresh. So everything but not fresh, all 5, is at least 1 is fresh. Because right here, this is how many movies are fresh, and we're saying everything but all 5 of them are not fresh. But we want, and the way it's highlighted above, is everything but all 5 movies are fresh. And if all 5 movies are not fresh, which means like the good rating, then we would see at least 1 is not fresh. Does that make sense? And always try to do a sense. Did anyone, hopefully this was a super quick problem. We did some of it yesterday. Really great practice. If you notice, we tied in the Marvel topic. So you're welcome, Marissa. So good to have everyone here. We don't got outro screens, but yeah, so we're going to head off here. And thank you, everybody. I'm going to figure out how to, wait, I don't even know how to close the stream. Okay, what's probably going to happen is the stream's probably going to stop. And so get ready for like an error. So here, I'm going to be in the chat and I'll be like, hey, did the stream stop? You're